Hello, you're welcome. All right, so we are looking at elementary functions. Okay, so we are going to start by defining a function. Okay, now, anytime we are talking about function is deals with mapping. Okay, a relationship between two sets. So that relationship is actually a relationship that associates the element of a set to another element, the element of a particular set with the element of other set. Okay, so it's just a relationship between sets, and this is how we represent the functions. That's why here I have function of A, okay, to B. That's what this represents. So function is always function of a particular set, okay, to another set. So this is function of A to B. F A to B, F A to B. All right. So now, how do we actually define function? Now, function from A to B is actually defined as a rule of correspondence which associate each element of A with exactly one element of B. So that rule that actually associate an element of A, the elements of A, okay, with exactly associate the element of A with the element of B. All right, one element of A to a particular element of B, and of course that happens by mapping. So you map the element of A to a particular element of B. Such rule is what is called function, right? So I hope that is well understood. Okay, so now we're just gonna look at it in a very simple. Okay, we are going to look at it, okay, with a very simple approach. All right, we're going to look at basic term that is used in function. Okay, one of the terms you should always be conversant with in a function is known as the image. Okay, the image of a function. Now, what is an image? Okay, now that unique element of B, since we are actually using, okay, set A and set B now as illustration. Okay, so that unique element of B, which actually is assigned to an element in A, is actually called the image of A. Now, I have to illustrate this using a typical example. Let's say you have function. This, of course, is this is element. This is set A, okay, and of course, this is set B. Now, of course, this particular function now maps all the elements from A to B, and that is why the arrow is pointing from A to B. Okay, so let's say A is have the set of A1, A2, A3, A4. So for B, I'm having B1, B2, B3, then B4. Okay, so let's start our mapping. Let's say I map A1 to B1. Okay, so it simply means that B1 is the image of what? Of A1. So it's just like you look yourself in the mirror, okay? What you see is your image. Okay, so A1 is the image of B1. Okay, let's say I map A2 to B3. Then I can also conclude that B3 is the image of A2. So I hope you understand what image. So that unique element, okay, in B that is mapped to a particular element is A is actually known as the image. All right. So let's say it's also possible for me to map. Okay. Let's look at map one that is two different elements in A to have one image. Is very much possible for that to happen, right? So it's very much possible for that to happen. Then let's say I map A4 to B4. So you discover that after all this mapping now, there are some element that doesn't have any there's some element in B, okay, which is not an image of any element in A, okay. So that will actually give us it will lead us to some other definitions, but let's we're going to take it one after the other. So we just use this now to illustrate our image. So this is how we define image of a function. Okay, so this is let's look at another term. So we're going to look at another term known as the domain, okay, and the codomain of a function. The domain and the codomain of a function. Okay, it's very important that you know all these terms. Now, simply, okay, for the domain of a function is the set of A. Domain, okay. So the domain of this function, of course, is the set. The entire set of A is called the domain. So please take note of that. So all the entire set of A, which of course is found at the left hand side, okay, are my domain. While the codomain, so invariably now, okay, so the domain of this particular function now that I have above, okay, example, the domain of the function I have is simply gonna be A1, A2, A3, and A4. Okay, so that's my domain. Then while the codomain, okay, of course that's where our mapping is actually getting to. So the codomain actually represent the set of B. So invariably now, my codomain is what I have, the entire set of B, which of course is B1, B2, B3, B4. Okay, so I hope that is well understood. So the set of A is my domain and the set of B is my codomain. Let's proceed. Now we're going to talk about there's another important term that we need to discuss. That's the range of a function. Okay, now the range of a function is just the set of the images, and of course you know the images is actually is found in the codomain, right? So the set of the image is found in the codomain. Now why will I actually call that the range? Of course you know that in a function, let me represent that function again. Okay, function of A to B. All right, here we go, in which I had A1, A2, A3, and A4, right? Then of course the codomain, I had B1, B2, B3, and B4. So you know that from B1 to B4 they are my codomain quite well, okay? But not all the codomain was actually mapped. Not all the codomain are actually my image, right? It's an image, right? Of course, this is how I actually did the mapping. I mapped A1 to B1. Okay, I remember mapping A2 to B3. Then I mapped A3 to B1. So you now discover that, okay, so the set, if I want to, the image, okay, the set of the image of this particular function now is simply the one that was already mapped. That's B1. Okay, B1, please pardon me, B1, okay. What again was mapped? B3 and B4. So it is this particular set now that actually forms the image of the function that we refer to as the range. But meanwhile, the codomain, okay, may not be, okay, there's some certain instances where the codomain, okay, can also be equal to the range. A situation where the codomain is equal to the range is actually in such a situation, it simply means that the entire element of the codomain is actually mapped. But in this case, not the entire element of the codomain is mapped. Okay, so not the entire element of the codomain, okay, an image of the domain A. So now, of course, if I really need to list out my codomain, which of course is all the element of B, all right, I'm gonna list out B1, B2, right, B3, then of course B4. So you discover that my codomain is not the same as my image, okay? It's not equal to my range. So please take note of that. So you need to understand the difference. Okay. So we still going to continue, okay? So now remember we said that a function is actually a rule, okay? So this function is a rule that actually establish mapping from A to B. Now, question is, how do we actually define that rule? That rule, okay, is always expressed in formula. Okay, so the rule is always expressed in a formula. So you don't just, the rule doesn't just come arbitrarily, okay? It's not just a random, there's a formula that actually specifies the rule. So let's look at the formula of a function. How do we express the formula of a function? Because it's a formula that actually uses a function, okay? Now, for us to express a function in a formula, okay, that formula must have a variable. Let's say the variable is x. So this is how we express it, f of x. Okay, for example, now say f of x is the formula for my function, and that f of x should have a definition. It's a formula, right? Let's say f of x is equal to s squared minus 1. So that means this formula, okay, f of x has the variable of f of x is s squared minus 1. So with this now, I can actually create a relationship between my domain, okay, and of course codomain. So let's say this particular function f of a. So anytime you have a function, there must be a formula that defines it. Okay, let's say first of all, let's say this is a function that maps a to b, and you be now is defined by. So okay, after the statement of the function, the mapping, the set where it is actually mapped from and the set where it's mapped to, then there must be a definition for it, okay? So it's defined by s squared minus 1. So you can actually, with this formula now, you can build the rule of correspondence of the function, okay? So which simply means that with this formula, I can now build my set. Now, the set of A is actually known as the variable for A, okay, is dependent, which simply means that I can just choose any arbitrary variable to, okay, let me just say real numbers. So I can just choose real numbers 1, 2, okay, 3, 4, then 5. Okay, then of course B. Okay, I can still choose, let me choose basically odd numbers. Okay, should I? Okay, should I choose odd numbers? Okay, let me just choose let me go by 0, 1, 2, 2, 3, 4, 5, 6, 7, just any number. So now let's actually map. So how do I map? I'll map. So my rule of mapping is going to be based on this formula. So what does this simply mean? Okay, so if I want to map, I will use my dependent variable is actually found in the dependent variable actually takes the value of the element of A. Okay, so I'm going to start with f of 1. That means when my domain is 1, okay, what exactly will I have as the codomain? Then I'll use this formula to do that. Okay, so that's going to be equal to 1 square minus 1. 1 square minus 1 is 0. So that means if I'm mapping now, mapping 1 to 0. Let's go again. Okay, when my domain is 2, so I will, to get what I have as the codomain, the image, I'll do f of 2, right? So the image of f of 2 is gotten by, of course, that's going to be 2 square. Quite well. Okay, then minus 1. 2 square is 4. 4 minus 1 is 3. So here map, here comes the mapping. So I can still do f of 3. Okay. Of course, this time around, of course, 3, that's going to be 3 square minus 1. Okay, that's that should be 8. So that is how it go. That's how we actually establish the rule or the formula of a function. So please take note of that. But you know very well that with this particular formula, okay, with this formula we only choose, that means the domain of this particular function. All right, I choose some numbers, starting from 1, okay, to 5. Now the question you ask yourself, assuming you are being asked, you are being given a function, the formula of a function, okay, how will you know the set of the domain? Will you just choose some numbers, or do you need to write all the entire numbers, or all the entire real numbers from 0 to infinity? Okay, and that is exactly what we are going to look at now. So let's look at scenarios where you are being asked to find the domain of a function given the formula of that function, right? Okay, so for example, okay, so the question is find the domain. Okay, of the functions. Find the domain of the functions. Given by the following. Okay, given by the following formula. So we're going to look at those formulas so we'll know how we're going. Okay, so what are the functions? A, we have f of x being equal to s squared minus 1. B, we have s squared minus 1. Okay, all over x. Then of course C, we have s squared minus 1 all over x plus 1. Okay, so solution. So how do I actually get the domain of this function? Okay, so if I want to list out the domain that will actually the set of elements or set of numbers that will, okay, that I can actually use in this function, then I can go from infinity to infinity. Okay, because any number you put in this function will definitely produce a valid image. It will produce a real image. So how do I write it? Okay, if I put 0 here, I will have a value. If I put -1, so how do I now represent the domain of this function? Okay, without listing out the real numbers from infinity to infinity. Okay, so I'm going to write it in a set builder form. Okay, I will write it in a set builder form. If you can still remember how we actually write our set builder. Okay, so we simply mean that if, okay, I'm starting with A now. So the domain of this function, all real number, okay, starting from the negative, all the negative real numbers to infinity, okay, then plus all the positive real number to infinity will be admissible. Okay, definitely it can actually form the domain of this function, because if I put those values, okay, into this function, then it will produce a valid image, a real image. Okay, so in as much as that particular value, if I put it inside this function, will produce a real image, okay, an image of a real number, then definitely that particular value is admissible. So how do I list out those values in a set builder? So look at how I write it. So my domain now is going to be equal to, okay, so I'll call it, let me call those number, call it x, of course. Okay, of course my variable here is x, so it's going to be all values that I'll put in x, or the value of x, such that, remember, okay, this is how we actually build ourselves, this set builder formula, okay, such that x is a member of all real numbers. X is a member of all real numbers, okay, without no exception. So all real numbers is permissible. All real numbers is permissible. Or you can actually write it this way. Because, okay, domain is a set of x, okay, such that from negative infinity is less than x, okay, and of course less or equal to x, and s is less or equal to positive infinity. Okay, please, this is symbol for infinity. So from positive infinity to negative infinity, then of course x is also belong to all set of real numbers. Okay, but I think this is actually shorter, so just, okay, saying that my domain is x, so that s is all real numbers. Okay, this is shorter. That is for my A. So all real numbers is permissible. But let's look at the case of B. Now the question is all real numbers permissible here? If I put all real numbers into this expression, will it give me a real number as an image? No. Okay, you know very well that this is a fraction. Okay, anytime the denominator of a fraction is equal to 0, then the value of that fraction becomes undefined. So you discover that all value of x is actually permissible, okay? It's admissible in this particular formula, except the value of x that will make this part, the denominator of this fraction to be equal to 0. Okay, so because if the denominator of the fraction is equal to 0, then definitely that particular value of x is not going to be one of the domain. Okay, there's going to be an exception. So now how do I write it in a set builder format? Okay, so I'll write it this way. Then the domain of that function is going to be, okay, all the set of x such that s is actually a member or belong to all real numbers. Okay, but there's an exception. X must not be equal to 0. Okay, so that's exactly how you write it in exams. But x mustn't be equal to 0. So it is only when x is equal to 0 that it is 0 that I have to, okay, remove from that the set of my domain. I hope that is well understood. Okay, so let's look at C. The same thing happens here. C is also a fraction. So, and of course, what is the value of x that will actually make the denominator of this fraction to be equal to 0? I know very well that if x is equal to -1, then the denominator of this fraction is equal to 0. So that simply means all real numbers is actually possible, okay, for the value of x, except, okay, s being equal to -1. So I can still write it in a set builder form. So my domain is going to be equal to set of x such that x, okay, is a member of all real numbers, but x shouldn't be equal to, okay, s shouldn't be equal to -1, because if x is -1 and -1 plus 1 is going to be 0, and that will make this particular fraction to be undefined. So I hope that is well understood. Okay, so that is how we evaluate the domain of a function given the formula of that particular function. So I hope that is well understood. Okay, so I will give you the opportunity to go through this. Please take note of all those basic terms: the domain, the codomain, the range, okay, the mapping, how to find the domain. So you need to go through them. Then as we actually return in the next video, we'll look at different type of function. All right, see you in the next video. Thank you very much.